This lesson's on 7.4, finding the lengths of the curve. So what we're going to do is we're going to take an actual curve and we're going to find the length of this. So for example, I call this the spaghetti problem. Let's say this is a spaghetti right there and I just pull it straight, right? And I want to know is what is actually that length of that spaghetti when it's pulled straight. So similar to that, that's what we're trying to figure out is all these different curves that we have, if we pull it straight, what would that length be? So we have two formulas that we're going to work with. One of the formula is L equals, then we have the integration of A to B. Now I'm taking the integration because if you remember from calculus AB, whenever you take the integration, you're finding the total distance. Well, similar to that, we're finding the total distance of that curve right there. Okay? The formula is also the square root of 1 plus the derivative. So in this case, it's the derivative of y equation. So example, like we have y equals sine x. So in respect of x squared, right, dx. And then the limits, we had said that it's on AB right here, A to B, if it's on the x-axis. Okay? Now, what if the graph is on the y-axis? Because we've had problems like that for AB. When we revolve things around the y-axis, remember we had to change the equation? So similar to that, we're going to have another equation for the graphs that are on the y-axis. So I have then the limits are C to D because these limits change, right? Because then it has to be on the y-axis limits right there. Okay? But the formula is exactly the same. The only difference is the derivative right here. Because you're going to have x equals, and then the rest of the equation, that's why you have the derivative of x in respect of the y, right? And squared dy. And so again, this is when the x graph is smooth on the y-axis right there. Okay? So again, the formulas are same. The limits are going to be the difference right there because it's either the x-axis or the y-axis you're reading. And then the derivative right there, that's going to be different as well. All right, so now let's take an example. So let's say I have an example y equals sine x, and the limits are between 0 to 2 pi. So if you can imagine the sine wave, right, between the 0 to 2 pi, we're trying to figure out what is that length of that curve. So we want to take the derivative of sine. So what's the derivative of sine? Right, cosine. So now let's put that into the formula. So the formula starts with square root of, right, 1 plus cosine squared dx, and the limits are 0 to 2 pi only because it's given to us. All right, so we put that 0 to 2 pi, put in the calculator, and you're going to get 7.64. Okay, now let's try example number 2. Example number 2 says y equals 4 square root of 2 over 3, x to the 3/2 power minus 1. And the limits, or the length of the curve that we're trying to figure out is between 0 to 1 on the x-axis. All right, so now we have to take is the first derivative. So the first derivative of this right here is that 3/2 is what we need to bring down, right? So we bring that down to the exponent, and then we subtract 1 on the exponent of that. The minus 1 will disappear because that's a constant. When you take a derivative constant, it's 0. Okay, so this is what it looks like. So we brought the 3/2 down, we subtract 1 on the exponent, gives us half right there. So now from here I can see that the 3's can cancel out and the 4 and 2 can reduce, right? Okay, so then when we do that, we're going to get 2 square root of 2, x to the half right there. So now that's the derivative, right? That's the dy over dx part of that. So now let's put it into the formula. The formula is 1 plus the derivative that we just found, right? Squared dx. And then the limits are from 0 to 1, only again because it's given for us 0 to 1. Okay? So we put that in the calculator, and the final answer is 13 over 6. Okay, now let's take an equation something like this. Y equals x to the 1/3. Now this right here, just from calculus AB, we're going to find that we cannot take the derivative of this, right? It's not differentiable. If you remember in calculus AB, there are 4 places where it's not differentiable, and this is one of those graphs. This is called a vertical tangent. Good. So because right here at this spot, I cannot take the derivative of this, right? That means that I cannot take the derivative of this equation. So what do? We have to switch this equation. We're going to have to make it into an x equals instead. So let me do that on the side right here. So we take this equation, and I need to cube this equation right here to get rid of the 1/3. So if I cube it, we're going to bring that cube on the y as well. So we're going to get y cubed equals x. Okay, so it's really an x equation that we're looking at. So what does that graph look like? Then this is the graph of x equals y cubed, which is kind of like an S shape right there, right? All right, so then from here, let me also bring out from pre-calculus. If you remember pre-calculus when we did inverse of an equation, I took the point right there, and I did the inverse, or I literally switched the x and y. So in this case, it's -8 and -2. If I switch it, it becomes -2 and -8. And then on same thing with this one. Up here it was positive 8 and 2. If I did the inverse of that, it becomes 2 and 8 right there. Okay, so that's how I know this right here, the inverse is correct. All right, now continuing on, we're going to take this equation, we're going to take the derivative of that and substitute into the equation to figure out, again, the length of this curve. So we have then, again, this equation right here. We're going to take the derivative, so it's actually then the dx that we're taking derivative of. And then we just bring the simple power down, right, and subtract 1. So that's what it looks right there. Okay, so now let's substitute this into that length of the curve equation. So the length of the curve is 1 plus 3 y squared, which we just took the derivative of right here, right? And we squared it, and it's dy, only because of this right here being y right here. Okay? Now the limits though is different because it's really the x equation that we took the limits for. So if you look at this graph, the limits on the x is negative 2 and positive 2. So that's why we took the limits from negative 2 and positive 2. Now this is one of those special cases, okay? So again, it's only when you have to switch the equation and have to do really the inverse of that right there, then you're going to have to figure out is what am I looking for. So I'm looking for is the x equation, so I find the limits of the x right there, all right? The rest again is in the calculator, and we get 17.26. Okay, that's it. So this will be the lesson for today. So now let's go ahead and do the homework problems for that.